Hi dear students, Namaste, good morning to you all and also welcome to another session of our mathematics class. In the previous session, we have discussed question number 1 to 10 from miscellaneous exercise of chapter 4 determinants. Hope you have revised well. And in today's session, we shall discuss the remaining problems from the miscellaneous exercise. Let's move on to the topic. Next, we shall discuss question number 11. The question is, using properties of determinants, prove that determinant alpha alpha square beta plus gamma beta beta square gamma plus alpha gamma gamma square alpha plus beta is equal to beta minus gamma into gamma minus alpha into alpha minus beta into alpha plus beta plus gamma. So let's take the given determinant which is on the LHS as delta. Delta is equal to determinant alpha alpha square beta plus gamma beta beta square gamma plus alpha gamma gamma square alpha plus beta. Here let's take the operation as R2 changes to R2 minus R1 and R3 changes to R3 minus R1. Here first row remains the same, that is alpha alpha square beta plus gamma. Then R2 changes to R2 minus R1. R2 minus R1 is beta minus alpha, beta square minus alpha square, gamma plus alpha minus beta minus gamma. So plus gamma minus gamma cancelled. You will get alpha minus beta, that is written. Next R3 changes to R3 minus R1, that is gamma minus alpha, that is written gamma square minus alpha square, then alpha plus beta minus gamma. So beta minus beta cancel, so alpha minus gamma will come. Then when you check here, this beta square minus alpha square, we can expand it by using alpha a square minus b square, that is a plus b into a minus b. So when you expand it, it will get as beta minus alpha into beta plus alpha. And here also gamma square minus alpha square we can expand it, that is gamma minus alpha into gamma plus alpha. After expanding, let's take out beta minus alpha and gamma minus alpha outside. So the first row remains the same, that is alpha alpha square beta plus gamma, that remains the same, and the beta minus alpha is outside, that means the balance is 1. Here beta square minus alpha square, in that as I explained before, by using a square minus b square we expanded. Out of that beta minus alpha is out, then beta plus alpha is remaining. Here alpha minus beta is there. From here we have taken beta minus alpha, that means 1 minus 1 is the balance. And in the next row gamma minus alpha we have taken outside, so balance is 1. As before, by using a square minus b square we have expanded this one. So alpha square minus gamma square minus alpha square is gamma minus alpha into gamma plus alpha. So gamma minus alpha is outside, balance is gamma plus alpha. Then alpha minus gamma is here, then we have taken gamma minus alpha outside, so it is minus 1 is the balance. Then R3 changes to R3 minus R2. R3 changes to R3 minus R2 in the sense we can make it this element 0, that is 1 minus 1 we will get it as 0. Again minus 1 minus minus 1, that is minus 1 plus 1, that element also will be 0. For that we are using this operation. Let's take that operation, that is delta is equal to beta minus alpha into gamma minus alpha. Then first row remains the same, alpha alpha square beta plus gamma. Second row also remains the same, 1 beta plus alpha minus 1. Then R3 is changing, R3 minus R2, 1 minus 1 0. Gamma plus alpha minus beta minus alpha. So alpha alpha is gone. Then gamma minus beta will be there. Then minus 1 minus minus 1, that is minus 1 plus 1, that becomes 0. Now when you consider the third row, two elements are 0. So we can expand easily along R3. When we expand the given determinant along R3, we get delta is equal to beta minus alpha into gamma minus alpha. That is the common factor which we have taken outside. And we are going to expand along R3. R3 is having only one element. The remaining two elements are 0. So first element 0, no need to take. The second element gamma minus beta. There is a minus sign we have to use since we are starting with the second term, that is minus gamma minus beta into that row and column is gone, alpha into minus 1, that is minus alpha, then 1 into beta plus gamma, that is minus 1 into beta plus gamma, that is minus we have to take inside, minus beta minus gamma, that is minus alpha minus beta minus gamma. Once again, this gamma minus beta we have to take, that row and column is eliminated, alpha into minus 1, that is minus alpha, minus 1 into beta plus gamma, that minus we have to multiply inside, that becomes minus beta minus gamma. So minus alpha minus beta minus gamma we have got. Here there is a minus sign which is outside, we can multiply inside the bracket, that is beta minus alpha into gamma minus alpha into, here there is gamma minus beta, that is written. This minus if you take inside, all negative signs becomes positive, that is alpha plus beta plus gamma. Then from here this beta minus alpha we can take one minus outside, then it becomes alpha minus beta, alpha minus beta into, then here there is gamma minus beta. Here from here also we can take a minus outside, it becomes beta minus gamma. So two minuses outside, it becomes plus. The remaining term same, that is gamma minus alpha into alpha plus beta plus gamma. So this is the right hand side we have to prove. Hence the given result is proved. Next we shall discuss question number 12. Question is, using properties of determinants, prove that determinant x square 1 plus px cube, y square 1 plus py cube, z square 1 plus pz cube is equal to 1 plus pxyz into x minus y into y minus z into z minus x. Let's take the left hand determinant LHS, that is determinant x square 1 plus px cube, y square 1 plus py cube, z square 1 plus pz cube. When you check the third column, it is sum of two terms. Here you can check 1 plus px cube, 1 plus py cube, 1 plus pz cube. By using the properties of determinants, the entire determinant we can split into two determinants. That is, the first determinant is x square 1, y square 1, z square 1. And the second determinant is x square px cube, y square py cube, z square pz cube. Let's take these two determinants as delta 1 and delta 2. That is, left hand side is equal to delta 1 plus delta 2. Consider delta 1, that is delta 1 is equal to x square 1, y square 1, z square 1. And in this determinant, the third column completely 1. So if we make two elements 0, then easily we can expand it. For that, we can take the operation R2 changes to R2 minus R1. That is 1 minus 1, this becomes 0. Next R3 changes to R3 minus R1. That means 1 minus 1, the third term will be 0. Let's write the operation. R2 changes to R2 minus R1, R3 changes to R3 minus R1. That is equal to, first row remains the same, x square 1. Then R2 is changing as R2 minus R1. That is y minus x, that is written. Second term will be y square minus x square. And the third element 1 minus 1, that is 0. And R3 changes to R3 minus R1. That is z minus x is the first term. Z square minus x square, that is the second term, and 1 minus 1, that is equal to 0. So here now when we check, there is a term y square minus x square, we can easily split as y plus x into y minus x by using a square minus b square. Here z square minus x square is there. This also easily we can factorize z plus x into z minus x. Means in the second row there is a y minus x common, and in the third row there is z minus x common. So let's take these two terms outside. Y minus x into z minus x into, first row remains the same, x square 1, and the second row y minus x is outside. So first term reduced to 1, and from here y plus x into y minus x, and y minus x is outside, balance is y plus x. 0 remains same. And from the third row, z minus x, if you take z minus x out, means first term will be 1. Z square minus x square we can split as z plus x into z minus x, that is z minus x outside, z plus x is the balance. 0 remains same. Next we can expand along C3. If you expand along C3, it will come as y minus x into z minus x into, only one element is there, that is 1 into, that 1 I did not write because 1 into any quantity is same quantity. That row column is gone, remaining determinant is 1 y plus x, 1 z plus x, that is written. Next is y minus x into z minus x into, let's expand it, 1 into z plus x, that is z plus x, minus 1 into y plus x, that is minus y minus x, that is written here. So minus 1 you are multiplying inside, that is minus 1 into y is minus y, minus 1 into x is minus x. That is x minus y into y minus z into, here there is a plus x and minus x cancelled, and z minus y is the balance, that is x minus y into y minus z into z minus x. That is y minus x into z minus x into, here there is a plus x and minus x is there, both we can cancel, the balance will be z minus y. So let's rearrange it, this one, this z minus y, from here we can take a negative sign outside, that means it becomes y minus z, and that is written here y minus z. Then here there is y minus x. Y minus x, from y minus x, if you take a minus sign outside, it becomes x minus y. So two minuses are out now, two minuses together, it is plus. So the entire term will change as y minus x will change as x minus y, and here there is a term that is z minus y, that will change as y minus z, and z minus x remains the same. So that is the value of delta 1. Next we can go for calculating delta 2. Delta 2 is equal to determinant x, x square px cube, y, y square py cube, z, z square pz cube. Then there is a px is common, sorry, there is a p is common in third column. Next we can consider delta 2. Delta 2 is equal to determinant x, x square px cube, y, y square py cube, z, z square pz cube. And when you consider the third column, there is a p outside, that we can take outside, and from the first row there is x common, that we can take. From the second row there is y common, that also we can take, and from the third row there is z is common. So x from the first row, y from the second row, and z from the third row. So x, y, z is outside, and p from the third column. So p, x, y, z is outside. Then the remaining determinant will be 1 x, x square, 1 y, y square, 1 z, z square. When you compare it with delta 1, the terms are there, only the order of columns are different. Here this delta 1 and this determinant, if you check, all the terms are there, but the columns are different. So let's go for rearranging it. That is equal to, first I am interchanging the third column and the first column, interchanging the third column and first column. That is, one time interchanging means there will be a minus sign, so minus pxyz into, this third column will come as first column, and the first column will go in place of third column. That is, first column will be x square, y square, z square, and the third column will be 1 1 1, and the second column remains the same, and there is a minus sign outside because we have interchanged one time. Next, again when we compare, the terms are there, but again order is different. First column and second column is different. So let's go for interchanging one more time. That is, C2 and C1 we can interchange. That time one more minus will come. That minus and this outside minus together, it becomes plus. That is pxyz into, when we interchange C1 and C2, first column will be x, y, z. Second column is this one, x square, y square, z square, and third column remains the same, 1 1 1. And this value we have already calculated, that is x minus y into y minus z into z minus x. Let's substitute, that is pxy into x minus y into y minus z into z minus x. So this is the value of delta 2. So we have calculated both the values, that is delta 1 is x minus y into y minus z into z minus x, and delta 2 is pxyz into x minus y into y minus z into z minus x. Now we have calculated the values of delta 1 and delta 2. Delta 1 is equal to x minus y into y minus z into z minus x, and delta 2 is equal to pxyz into x minus y into y minus z into z minus x. Let's substitute these two values in LHS, that is LHS is equal to delta 1 plus delta 2, that is equal to delta 1 we have x minus y into y minus z into z minus x, and delta 2 we have pxyz into x minus y into y minus z into z minus x. And when you consider these two terms, there is a common term, that is x minus y, y minus z, z minus x is common in both. So let's take it out, that is x minus y into y minus z into z minus x, and the first term completely gone out, the remaining term is only 1 plus, and from the second term this 3 x minus y, y minus z and z minus x are gone out. The balance is only pxyz. So that is written here. Little bit of rearrangement, that is 1 plus pxyz into x minus y into y minus z into z minus x. This is our RHS, and hence it is proved. Next we shall discuss question number 13. The question is, using properties of determinants, prove that determinant 3a minus a plus b minus a plus c minus b plus a 3b minus b plus c minus c plus a minus c plus b 3c is equal to 3 into a plus b plus c into ab plus bc plus ca. Let's take the left hand side determinant as delta. Delta is equal to determinant 3a minus a plus b minus a plus c minus b plus a 3b minus b plus c minus c plus a minus c plus b 3c. Here when you observe this delta or the given determinant, when we consider the operation, C1 changes to C1 plus C2 plus C3, means C1, C2, C3 if we add, let's check it, 3a minus a, that is 2a, 2a minus a is a, means a plus b plus c, the first term. Next is here minus b is there, then plus 3b, that is minus b plus 3b is 2b, 2b minus b is b, plus a plus c, that means this element also a plus b plus c. And the third element if you consider minus c, that is minus 2c plus 3c, minus 2c plus 3c is c, plus a plus b, that is this term also a plus b plus c, means a plus b plus c we can take common from c1. So let's consider that operation. C1 changes to C1 plus C2 plus C3, that is equal to a plus b plus c, a plus b plus c, a plus b plus c. First column completely a plus b plus c, we have discussed before. Second column no change, third column also no change. From first column we can take a plus b plus c as common outside, that is a plus b plus c into determinant. First column completely changes to 1, that is 1 1 1, and the second column same, and the third column also same, that is minus a plus c minus b plus c 3c. Now this determinant we can easily calculate. We have to change two elements from C1 to 0. That means these two elements, if we make it 0, then the calculation will be easy for us. For that, the operation is quite familiar for us. That is R2 changes to R2 minus R1. That means 1 minus 1. This element will be 0. Again, one more operation. R3 changes to R3 minus R1. That means 1 minus 1. This term also will be 0. Let's go for the calculation. Delta is equal to a plus b plus c into, first row remains the same, 1 minus a plus b minus a plus c. And the second row, that is R2 changes to R2 minus R1. That is 1 minus 1, 0. Next is 3b minus of minus a plus b. That is 3b plus a minus b. That is 3b minus b is 2b. 2b plus a. Next is minus b plus c minus of minus a plus c. That is minus b plus c plus a minus c. So here c minus c will be cancelled. Finally a minus b will be the answer. Next R3 changes to R3 minus R1. Again 1 minus 1, that is 0. Next minus c plus b minus of minus a plus b. that is minus C plus B, when you remove the bracket, plus A minus B. That means the result plus B and minus B will be cancelled and the final answer becomes A minus C. Third element, that is 3C minus of minus A plus C, that is 3C plus A minus C. So we will get as 2C plus A. As I mentioned before, these are all mental calculations. If you feel difficulty, please take a piece of paper and do the rough calculations and write the final answer. Then next, expanding along C1, we have delta is equal to A plus B plus C into C1. There is only one element, the remaining two elements are 0. So 1 into that particular row column is gone, that is 2B plus A into 2C plus A, that is written 2B plus A into 2C plus A minus A minus C into A minus B, that is written. Let's go for the calculation, that is A plus B plus C into 2B into 2C, that is 4BC, then 2B into A, that is 2AB, the next is A into 2C, that is 2AC, A into A, that is A square. Here there is a minus outside, this minus we have to take inside and then we have to multiply. Here A into A square, there is a minus outside, so minus A square. Next is A into C, that is minus AC, there is a minus sign here. A into minus C, that is minus AC, there is a minus outside, two minuses together, plus AC. Then next is B into A, that is BA, here there is a minus, so minus BA, and outside minus joining means it becomes plus BA. Then again B into C, that is minus into minus plus BC, there is a minus outside, so it becomes minus BC. So go for the calculation, that is A plus B plus C into here 2AB plus AB. 2AB plus AB is 3AB. The next is 4BC, then again minus BC. 4BC minus BC is 3BC, and AC term if we consider 2AC, then plus AC, that is 3AC. Plus A square minus A square will be cancelled. So we will get the answer as A plus B plus C into 3AB plus 3BC plus 3AC. That is 3 into A plus B plus C. There is a 3 common in second term. We can take outside 3 into A plus B plus C into the remaining term is AB plus BC plus CA, because 3 is outside. So the final answer becomes 3 into A plus B plus C into AB plus BC plus CA. Hence the given result is proved. Next, we shall discuss question number 15. The question is, using properties of determinants, prove that determinant sin alpha cos alpha plus delta, sin beta cos beta plus delta, sin gamma cos gamma plus delta equal to 0. Left hand side determinants, let's take as delta. Delta is equal to the given determinant, and we have to expand the third column by using cos A plus B formula, that is first column remains the same, second column also same, third column cos A plus B formula if we use cos alpha cos delta minus sin alpha sin delta, and again cos beta plus delta will change as cos beta cos delta minus sin beta sin delta, and cos gamma plus delta will change as cos gamma cos delta minus sin gamma sin delta. The rest of the calculation you have to do it as homework, and I will explain the procedure. Here the third column, when you check, it is the difference of two terms, means the entire determinant we can split as two determinants, and in the first determinant it will come as first column same, second column same, and the third column will come as cos alpha cos delta, cos beta cos delta, cos gamma cos delta, and minus the second determinant also, first column second column same, third column will come as sin delta, sin alpha sin delta, sin beta sin delta, sin gamma sin delta. And when you check the first determinant, there is cos delta common, take outside, and in the second determinant there will be sin delta common, take outside. Then just observe the two determinants. In that two determinants, two columns will be identical, and in the first determinant cos alpha cos beta cos gamma, and again cos alpha cos beta cos gamma, that is C2 and C3 will be identical. Two rows or columns identical means the value will be 0. In the second determinant also same thing, that is sin delta if you take outside, sin alpha sin beta sin gamma will be there as C3, and the first column, that is C1, if you check, that also sin alpha sin beta sin gamma. That means in the second determinant also two columns C1 and C3 will be identical, means that value also will be 0. So Just to proceed, 0 minus 0, that is equal to 0. So we have to find out the answer as 0, or we have to prove the answer as 0. So that is the way you have to proceed. Please try this at home as homework. Move on to question number 16. The question is, solve the system of the following equations. 2 by x plus 3 by y plus 10 by z is equal to 4. 4 by x minus 6 by y plus 5 by z is equal to 1. 6 by x plus 9 by y minus 20 by z is equal to 2. Here, let's take 1 by x as p, 1 by y as q, 1 by z is equal to r. So the given equation will change as 2p plus 3q plus 10r is equal to 4. Second equation will change as 4p minus 6q plus 5r is equal to 1. And the third equation will come as 6p plus 9q minus 20r is equal to 2. So this is quite familiar for us. By using matrix method, we know how to solve it. The given system can be expressed in the form Ax is equal to b. Then we have to write A, that is a coefficient matrix. X is the variable matrix and b is the constant matrix. By using that, we have to calculate the values of p, q and r. Here the variables are p, q and r. Once you get the values of p, q and r, we have to substitute here 1 by x is equal to p, 1 by y is equal to q and 1 by z is equal to r. Then we have to get the value of x, y and z. So this question you will try it as homework. Next we shall discuss question number 17. The question is, choose the correct answer. If a, b, c are in AP, then the determinant x plus 2, x plus 3, x plus 2a, x plus 3, x plus 4, x plus 2b, x plus 4, x plus 5, x plus 2c. There are 4 options given to you. First option is 0, second option 1, third option x, and the fourth option 2x. The given condition is a, b, c are in AP. Since a, b, c are in AP, the common difference will be same. Means b minus a will be equal to c minus b. So let's take the given determinant as delta. Then go for the operation. R2 changes to R2 minus R1 and R3 changes to R3 minus R2. So R2 and R3 we are changing. After going for the calculation, just first row remains the same, that is x plus 2, x plus 3, x plus 2a. R2 is changing as R2 minus R1, that is x plus 3 minus x minus 2. So x cancelled. Then 3 minus 2. 3 minus 2 is 1. Next is x plus 4 minus x minus 3, that is 4 minus 3, 1. Then again x plus 2b minus x minus 2a, means 2b minus 2a. From there 2, if we take outside, 2 into b minus a will come. R3 changes to R3 minus R2, that is x plus 4 minus x minus 3. So x cancel, 4 minus 3 is 1. X plus 5 minus x minus 4, that is x cancelled, 5 minus 4 is 1. X plus 2c minus x minus 2b, means x cancelled, 2c minus 2b will be there. From that 2, if you take outside, c minus b will get. 2 into c minus b will get. Then the determinant will come as x plus 2, x plus 3, x plus 2a. First row remains the same. Next is 1, 1, 2 into b minus a. That is the second row. And the third row we can go for a little bit of arrangement. That is c minus b we can replace as b minus a. That is 1, 1, 2 into the c minus b will change as b minus a. Now when you look at the determinant, second row and third row are identical. 1, 1, 2 into b minus a, 1, 1, 2 into b minus a. Here row 2 and row 3 are identical, means the value is 0. So the correct option is A. A is the correct answer. Next we shall discuss question number 18. Choose the correct answer. The question is, if x, y, z are non-zero real numbers, then the inverse of matrix A is equal to matrix x 0, 0, 0, y 0, 0, 0, z is. First option, A is equal to matrix x inverse 0, 0, 0, y inverse 0, 0, 0, y inverse. Second option is x, y, z into matrix x inverse 0, 0, 0, y inverse 0, 0, 0, z inverse. Third option is 1 by x, y, z into matrix x 0, 0, 0, y 0, 0, 0, z. And the fourth option is 1 by x, y, z into matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. It's a very simple question. because we know how to calculate the inverse of a matrix. So let's take the given matrix A. Then we have to go for determinant A. Determinant A is just we can expand along the first row. Then first row, if you consider only one element is there, the remaining two elements are 0. X into that row and column is gone. Y into Z is YZ, minus 0 into 0 is minus 0. So XYZ, which is a non-zero number, which is not equal to 0. Therefore, A inverse exists. Then we can go for finding A inverse directly. A inverse equal to adj divided by determinant A. So first we have to find out the cofactor matrix. Then adj we have to calculate. Adj by determinant A will be the answer. So this you will try it. Next we shall discuss question number 19. That is the last question of this chapter. Choose the correct answer. Let A is equal to matrix 1 sin theta 1 minus sin theta 1 sin theta minus 1 minus sin theta 1, where 0 less than or equal to theta less than or equal to 2 pi. Then there are four options given to you. First option dta equal to 0. Second option dta belongs to open interval 2 infinity. Third one determinant A belongs to open interval 2 4, and the fourth option determinant A element of closed interval 2 4. We have to choose the correct answer. Here determinant A is mentioned, so we have to go for calculating determinant A. Let's take the given given matrix as A. A is equal to the given matrix, it is written. Then determinant A we will calculate 1 into that particular row and column is gone. 1 into 1 is 1, minus into minus plus, sin theta into sin theta is sin square theta. Second element sin theta, then the sign is minus, minus sin theta into that row column is gone, minus sin theta into 1 is minus sin theta, minus into minus plus, 1 into sin theta is sin theta. Third element, that is plus 1 into that row column is gone, minus sin theta into minus sin theta is plus sin square theta, minus into minus plus, 1 into 1 is 1, so sin square theta plus 1. Go for expansion, that is 1 plus sin square theta. Here the term is 0, minus sin theta plus sin theta is cancelled. Then last term 1 into sin square theta plus 1 is sin square theta plus 1. That is 2 plus 2 sin square theta we will get. Then if you take 2 as common, 2 into 1 plus sin square theta. As we know that the sin theta, the value of sin theta lies between minus 1 and plus 1. And when you square it, the value of sin square theta lies between 0 and 1. Then we need to bring this 2 into 1 plus sin square theta format. That means we have to just add 1, because we need 1 plus sin square theta. In this inequality, just adding 1, that is 1 plus 0 is 1. Sin square theta, if you add 1, 1 plus sin square theta, 1 plus 1 if you add, it becomes 2. Next, we need 2 into 1 plus sin square theta, means we need to multiply 2 throughout the inequality. That is 2 into, here 1 into 2 is 2, then 1 plus sin square theta, if you multiply 2, that is 2 into 1 plus sin square theta less than or equal to 2 into 2 is 4. That is, the correct answer is D, means here 2 less than or equal to our DTA, determinant A value is 2 into 1 plus sin square theta less than or equal to 4, means between 2 and 4 both inclusive. That means closed interval 2 4. So option D is the correct one. Dear students, today we have discussed question number 11 to 19 of miscellaneous exercise from the chapter Determinants. Hope it is clear for you all. And with that questions, we have completed chapter 4. And if you have any doubt, please write it and keep. We will discuss it during the online session. Thank you for watching.